So hello 11th class students, welcome to Career Platform. So guys, this is going to be the very first lecture of subject physics of class 11. So क्या कहते हैं, I hope क्या कहते हैं आपका first lecture हो and it is going to be amazing. So the very first topic, the very basic topic that we are going to start about in physics is scalars and vectors. So we are going to complete the entire chapter today. Okay, so let's start with scalars and vectors. तो गाइज व्हाट इज बेसिकली अ वेक्टर? वेक्टर्स होते क्या है और स्केलर्स होते क्या है? सी स्केलर्स आर दोज सी क्वांटिटीज. सो सबसे पहले समझते हैं व्हाट आर क्वांटिटीज. व्हाट डू वन मीन बाय क्वांटिटीज? सो क्वांटिटीज आर समथिंग दैट कैन बी मेजर्ड, that can be evaluated, that can be determined. So if we start measuring a quantity, we say that we can measure a quantity. So if there is a quantity, it can be measured or it can be valued or it can be brought down to a numbers that we can measure it to some extent. So what are scalars? Scalars are numbers. Okay, so quantities that have magnitude only. That this only is a very important word. See, only is the one of the most important word. It's not saying that magnitude with direction. No. Direction is the second factor. We are talking about magnitude only. So quantities that have magnitude only are scalars. So what are scalars? Quantities that have magnitude. So what do we understand by magnitude? Okay. So what do we understand by the term magnitude? Magnitude means its value. For example, we walked a distance of 5 kilometers. So what is the magnitude? What is the measure? The measure is 5 kilometers. ठीक है. So its magnitude becomes 5 kilometers. ठीक है. But on the other hand, what are vectors? Vectors means that they have direction also. We are going to discuss in detail further. So let's go and discuss about these things. And so yeah, scalars. Okay guys, so see, now we are going to talk about scalars. So what are scalars? Quantities that have only magnitude. This only is a very important, guys. This only is a very important word. The quantities that have only magnitude are called as scalars. So for example, let's take distance. Distance. So basically what is distance? Distance is the path traveled. Distance is not the shortest distance. What is distance? Distance is path traveled between 2 points. Am I right? Between 2 points. So suppose there is a point A and we are going in any direction to the point B. Okay, so we followed a path. So see what happens. So the distance, if suppose the distance between A and B point is, the distance from A point to B point is suppose 10 kilometers. Okay, so 10 kilometers is what? Its magnitude. See, we have to keep thinking, we have to remind about this thing that it does not have any kind of direction. It does not have any kind of direction. It has only magnitude. It's not saying that it is going in north. It's not saying is that the man is going in south, in east or west. Nothing. It is just saying what it is saying. It is saying that it is going in no particular direction. Only like no direction is defined, only the value is defined. That is 10 kilometers. ठीक है, ये हमें बहुत ध्यान रखना है कि the no direction is defined. There is no role of direction when we are talking about the scalars, but there is obviously the role of direction in when we are talking about vectors, but there is no role when we are talking about scalars. So what are scalars? Quantities that have only magnitude, जिनका सिर्फ magnitude, they have nothing else. So these kind of things, these kind of quantities, what do we call them? Scalars. Am I right, guys? Is this okay? Is this clear? Is this understood? So what are scalars? Scalars are quantities that have magnitude only. So let's take more examples. So the first example that we have taken is distance. Is there any other example? Yes. The other example is speed also. See, what is the speed? Speed is distance traveled per unit time. So suppose a man is going at a speed of 100 kilometers per hour. Is there any direction defined in it? No direction is defined here. No particular direction is defined here that he is going in east or north or towards Delhi or towards Noida. Nothing is defined. What is defined? That there is a speed. So it is a quantity which has only number, which has only value, which has only magnitude. That is 100. No direction is defined. Let's take one more example, which is, let's take mass, etc. Like mass, a body has 50 kg. It's not like body has 50 kg Towards what? Towards earth or towards moon? Nothing is defined. Only the value, the magnitude is only defined. So these quantities are called as scalars. Is this okay? Okay. Okay, so let's move ahead. And with this, okay, vectors. Let's come to the main topic, which is vectors. So scalars are, those have magnitude only. So what are vectors? Quantities that have magnitude along with the direction. Direction is the one of the most important factor here. There was magnitude here, magnitude along with the direction. So the direction is also defined here. There is no any particular value without any direction. Okay, so quantities that have magnitude along with the direction are called as vectors. Example, velocity. See, what is the basic difference? People ask me what is the basic difference between speed and velocity. See, the basic difference is speed has a value, velocity has a value. A man is going at a speed of 10 km per hour, and a man is going with a velocity of 10 km per hour towards north. The value is the same, the magnitude is the same, but it does not have direction. It also have direction, that is north. So this is one of the basic example. This is one of the basic difference between the scalars and vectors. There are many properties that we will learn about, we will study about, but the basic thing is what is it? It's the direction. Quantities that have magnitude along with the direction are called as vectors. For example, velocity, acceleration, force. Let's talk about force. See, force means we are going to push something. So suppose this is a LED and I'm going to push it. So obviously when I'm going to push it, I'm pushing it this direction. Now I am pushing it. Or for example, if there is a man standing right behind me and I'm going to push it, so I'm pushing him in this direction. I'm not just pushing him. I have to push him in one particular direction. I can't push him in no direction. I have to push him in one direction. So the direction has to be defined when there is a magnitude, when there is a value. So this is the basic thing, quantities that have magnitude along with the direction. This is one of the most important things that we need to learn about. Quantities that have magnitude along with direction are called as vectors. For example, velocity, acceleration, force, etc. Is this clear? Is this clear? Is there any doubt? Okay. See, now there are two types of vectors, polar vectors and axial vectors. So sir, what are polar vectors? What are axial vectors? See, polar vectors are something which, polars. Polar means pole. So something that is, those are linear, I would say. I would like to say that vectors which are, line to in one direction. They are not like going in all directions. They are just line to one direction. For example, force. Polar vector examples are force, like force, like you are applying in one particular direction. But whereas on the other side, axial vectors. What are axial vectors? The axial vectors can be considered as rotational vectors. Rotational it means there is a kind of rotation that is being processed. So axial vectors, there is a axis. Suppose there is a axis and there is a vector that is rotating itself around that axis, and those are what, these kind of vectors are called axial vectors. Okay. So what is the basic difference between axial vectors and polar vectors? Polar vectors are assigned to one direction, whereas axial vectors are assigned around an axis. They are being rotated, they are being assigned around an axis. Okay, is this clear? Am I clear? Okay. Okay, so let's also talk about the types of vector. See, modulus of a vector. This is a very important thing. What is modulus of vector? We have understood that the scalars are something that has value. Vectors is something that has value along with the direction. Direction is also associated with the value. So how do we know the value? That what is the value? See, one thing I also wanted to talk about. Okay, a vector. Suppose let's take a vector. Okay, let's take this. Okay, let's take we have vector A. So how do we know it's a vector? We will know it's a vector by putting this arrow sign. So does the vector be represented by this? Yes, the vector is represented by this. And how do we represent a vector? We have this tail. You know, in Hindi we call it a pooch. You know, it's a tail. It is called a tail of a vector. Tail of a vector. It's like a ray. Tail of a vector, and it is called as tip of a vector. And it is called as tip of a vector, or we can also call it as head of a vector. Is that clear? This is called as tip of a vector, this is called a tail of a vector. And in which direction this arrow is there, this is the direction of the vector. This is the direction of the vector we are talking about. For example, if this is a b direction, you know, this is the b vector, and we can't write it as just b. We can't write it as just b. We have to put an arrow along with it. Okay, is that clear? Do we have any doubt with it? Let's move ahead. So there is this types of vector. So what do we understand by the first thing, that is modulus of vector? I've just talked about that vectors have direction, but the basic thing is that they also have magnitude, that they also have they are also assigned with some kind of value. Okay, so what is modulus? Suppose a vector, okay, this is the vector, it is assigned to the direction of, suppose, east. Okay, it is assigned to the direction of, suppose, east. We have assigned it to direction of east. Okay, now suppose it has its value 5, but how do we write it? How do we know that it is assigned to value when we have to represent it mathematically? So what we'll do, suppose this is a vector, you know, we have taken this a vector, and we will put a modulus on it. And when we will put modulus on it and we will write something equal to it, it will be the value or the magnitude of the a vector. Is that clear? When we are going to write the modulus on a vector, the value coming out of this, it will be going to the magnitude of the vector, the vector that is being processed. So for example, here is 5. So 5 is what? 5 is the modulus of a vector. What do we understand by modulus? Modulus means its value, its magnitude. Okay guys, is that clear? Okay, good. So now let's move ahead. What do we understand by unit vector? See, unit vector is something when the value, the magnitude of a vector is 1. What? When the magnitude of a vector is 1, it is called as a unit vector. And how do we represent it? Suppose we have taken in an vector. Let's take what? Let's take any alphabet. Let's take x. So the x vector is 1. Okay, is that clear? What is its value? It's x. So how do we write it? How do we represent that? How do we know that it's a vector but a unit vector? When we put a cap on it. If there is a cap on any kind of alphabet, it is called as unit vector. Okay, so what is the unit vector? It is a vector that has value 1. That is unit value. Okay, equal vectors we know. Suppose this is a and suppose this is b. B vector, a vector, which have equal value and equal direction. So these are called as equal vectors. See, there is a difference between this and this. This means their value are equal. It can be this. Their values are equal, but their directions are opposite. It means their values are equal and their directions are also equal. Their directions are also same. So this is the main thing that we need to talk about, that we need to understand, that we need to keep reminding ourselves. Okay, is this clear? Are we getting good at it? Is there any problem is there any kind of problem that we are facing? So everything going good? Great. So modulus of vector. So if we start thinking that how to represent, you know, its value, so what we do, we write the modulus over the vector and we write its value. This will be the modulus of the vector. What does it represent? It represents the magnitude. Unit vector, when its value is 1, and we represent it by putting a cap on it. For example, a cap. If b unit vector, b cap, c is a unit vector, c cap, and so on. So equal vectors. So what are equal vectors? So equal vector is basically vectors which have same magnitude and also same direction. Okay guys, I hope this is clear. Okay, so let's move ahead. Okay, so negative vector, this is very important. Let's take a vector A. So we have taken a vector A vector. Now let's take a same vector with the same value. Let's keep it horizontal. Suppose this is A vector and this is B vector, but in what direction? In opposite direction. See, now as we have discussed about, their magnitudes are same, their magnitudes are same. So are you agreeing with this? But the directions are opposite. So how do I write it? Is this, will this be equal? Yes, this will be equal, but in negative sign. It means if it is going forward, then you are going away, more and more away from the A vector. Okay? So this is negative. What are negative vectors? So negative vectors means vectors that have same magnitude, that have same kind of value, that have same magnitude, but they are in just opposite direction. If it is in north, the other doesn't have to be in east or west, it has to be in south. If one is in west or if one is in east, it has to be the other one, right? Do we got it? Great. So co-initial vectors, let's come to the next topic. Co-initial vectors. So what are co-initial? What is the next type of vector? Co-initial. Co-initial means, co means same, co means two and it has same. Initial, when two vectors have the same initial point. These are two vectors and they both are starting from, let's take a point O. So this is a vector and this is a B vector. Suppose they both are starting from a point, from the same point O. So this is going to be A vector and this is going to be the B vector. So co-initial vector is something that have the same initial point, that have the same starting point. So those kind of vectors, we call them what? Co-initial vectors. Is this clear? Is this clear? Is this understood? Do we have any problem? Any kind of problem? So can we go ahead? Great. So null vectors, you know, null means empty, that is nothing. So null vector is what? Suppose there is a vector A. So if there does not exist any A vector, if it has no existence, so what will happen? Does this have to have any value? No, there would be no value associated with it. So what will happen? It's simply its value will be, its value will be 0. So null vector is something that is, it means if we have to represent an empty vector or a null vector, how would we represent it? By putting its magnitude equal to 0. Is this clear? Do we have any problem? Is this all right? Okay. Okay. So let's come to the next topic. Multiplication. Okay. Multiplication and resultant of a vector. Suppose we take a vector whose magnitude is 5. So its magnitude is 5. Okay. Is this clear? Its magnitude is 5. Now what will happen? Now there is another vector. Another vector is taken. That is b vector, which is double the value of the a vector. So which is twice the value of a vector. So basically the vector b is derived from the vector a. Okay. So what will happen? A vector has some kind of length. So b vector will be just double to it. So if this is a, if it has 5 value, then the value of the b is 10. So what do? We multiplied the vector by a scalar. And what is the scalar value? A. You know, we multiplied the vector by the value 2. So what do we understand? If we take a number n that belongs to let's take n that belongs to natural number, that is 1, 2, 3, 4, 5 and so on. So what will happen? And if we are multiplying the number small n by a vector, let's take a vector. So what will happen? Its magnitude will be simply multiplied If it is 2 a vector, so it is will be multiplied 2 times. If 3 times, 4 times, 100 times, keeping the direction same. This is very important, keeping the direction same. Okay, is this clear? Am I understood? Okay, great. So multiplication is a very simple concept. Resultant also, see, if see, सबसे पहले we need to understand what is resultant. What is the first thing that needs to come to our mind when we are talking a resultant vector? So basically, what is a resultant vector? See, suppose you have two vectors. Okay, one has one has some value, other has also some value. So if there is a vector and if there is b vector, and one is saying that the resultant of these two is r vector. So by this statement, we understanding that the r vector will be producing the same effect, the same kind of effect that a vector and b vector are creating together. So suppose a vector is showing some impact, it has some magnitude, it has some direction, and b also has some value and some direction. So those all impact, those all magnitudes and direction, they can represent, the r will represent the r will represent it alone. So how do we calculate the value of r? There is a particular formula that we need to understand, which is r equals to a vector magnitude of a. Okay, there is a formula that is defined. How that is defined? That is defined on the magnitude basis, on the value basis. Okay, so a square plus b magnitude square plus 2a cos theta. And so what is this cos? You will be asking, sir, what is this cos? We didn't understand. See, let's take this is a vector, this is b vector. So the resultant of these two, let's take this vector. So and its value will be root of a square plus b square plus 2ab cos theta, and theta being the angle between the a and b. Theta being the angle between a and b. Is this clear? Am I clear? Am I understood? Do we have any problem with this? Is this going all right? So what is the value of r? Root of a square plus b square plus 2ab cos theta, keeping not ab as a vector but the magnitudes of a and b vectors. ठीक है? Clear? Multiplication resultant of a vector. Okay, so let's move ahead. Okay, so let's come to our next topic, triangle law of vectors. See, the word triangle is specified here. So what are triangle of vectors? Suppose we have just talked about the resultant of two vectors. Suppose, as we know, this is a triangle. It has its sides 1, 2, 3. How many sides does it have? It has one side, it has two sides, it has third side. First, second, third. So it has basically 3 sides. So the triangle law of vectors, the triangle law of vectors states that if the two sides of a triangle are representing the vector in one order, and what do we mean by one order? That this is first, this is second. Okay, the two sides, so the third being these are the first two sides taken in the same order. And when we talk about taken in the same order, we don't talk like this, like the arrow is here or the second arrow is there. It has to be in one direction. So suppose this is here and this instead of being here, the direction would be here. It's not possible. Okay, so taken in one order. Suppose this is a, and this is, like this is a vector and this is b vector. The resultant of 2 will be the third side. But very important thing, where is the order going? This is first, this is second, so third would be like this. This is first, this is second, so the third would be like this, but in opposite order. Here it is going like this, so this, So it has to be this? No. But the resultant has to be in opposite direction. So if the first two sides of a triangle are representing two vectors taken in one order, their resultant, the resultant of what? The resultant of A and B R will be the third side of the triangle taken in opposite order. So R vector equals to A vector plus B vector. Is this clear? Am I understood? Is this clear? Is this basic, students? What we have done, this is a very simple concept. This is a triangle, this is the first side of the triangle, this is the second side of the triangle, this is the first side of a triangle, this is the second side of triangle. A is on the first side, B is on the second side, so the third side but on the opposite order will be the resultant of the first two, Is this clear? Do I have any problem with this? Can we move ahead? Can we go forward? Okay. Okay, it has coming. Okay, so let's talk about, now we have discussed vectors, what are scalars, what are polar vectors, co-initial vectors, empty vectors, null vectors, equal vectors, you know, and almost all kind of vectors. And we have discussed the triangle law. Now the parallelogram law. See, these two laws are very important. You know, from this chapter we usually, you know, the questions, the examiner, your teacher mostly asks from these two topics. First being the triangle law of vectors, and second being the parallelogram law of vectors. So what a parallelogram? See, in triangle, a triangle is associated with all the definitions. So in parallelogram, a parallelogram is going to be associated. So let's take a parallelogram. What is parallelogram? You know, those opposite sides are equal. It means this side and this side is equal, and this side and this side is equal. This is a parallelogram, right? And what else? Angles are opposite angles are equal. Anything else that we need to understand? No. Okay, one more property, then we'll complete almost the entire properties of the parallelogram. These diagonals cut each other. Okay, but they do not have 90-degree angle. Okay, this is the thing that we need to understand. So a parallelogram is associated. So let's draw a parallelogram first. The parallelogram law of vector says, if, let's put it C better. If the two adjacent sides of a parallelogram, see, parallelogram has four sides. If we take any two sides on a triangle, they are going to be adjacent. But it's not the same case for the parallelogram. So for example, if we are taking we can take these two sides, but these are not adjacent. So what we need to understand is, we take any two sides on parallelogram, the resultant vector, if we take any two sides on a parallelogram, and these two adjacent sides are representing two vectors. Suppose let's take a point, and this is basically, let's take what okay, let's not take vertices, let's take vectors. Okay, so suppose this is a vector, this is b vector, and this is p. Okay, this is better, this sounds good. Okay, so this is p, q, r, s. So this is a vector and this is the b vector. So these are the two adjacent sides, and we are taking the two vectors at two adjacent vectors. So the resultant, now what will be the resultant? The resultant of these two adjacent sides, of these two adjacent vector that we have taken on two adjacent sides, the resultant will be the diagonal of the vector. Okay, so which diagonal? The diagonal from the common vertices, from the common point of the two initial vectors. If let's take this is a, this is b, you know, now this is c, and this is d, and p, q, r, s. See, so now also there are two diagonals. There are two diagonals. Obviously, there are two diagonals. So now what will happen? This is A and D. Now we have to calculate of A and B. Let's take A and B. These are also two adjacent sides, and these are also two adjacent vectors. So what will happen? This middle vector, this diagonal, sorry, this diagonal that is going, we are not going to take this one because this is not the common point between the two sides that we are taking the vectors on. This is not the common side. This is the common side. Okay, this is the common side, so we have to take this diagonal associated with this vertex. Okay, so from this vertex, the diagonal associated will be the resultant vector. So our vector is going to be equal to the A vector plus B vector. Am I understood? Is this clear? Do we have any problem? So let's take a brief look at it on it again. We have a parallelogram. We take any two adjacent sides. Okay, we take any two adjacent sides. So the resultant will be the diagonal that is connected to the common point of the two adjacent sides that we have taken the vector on, and the diagonal, the vector on the diagonal will be the resultant of the vector of the two vectors that we have taken on the adjacent sides. That is R vector equal to A vector plus B vector. Is this clear, students? Is this clear? And if you ask, so this is the basic formula. Okay, let me write it in a good way. So this is the basic formula. R vector equals to A vector plus B vector. But if we talk about the magnitude of R vector, so what it is going to be like? We have just talked about A square, magnitude of A square plus B square plus 2 AB cos theta. Is this clear, students? Am I understood? Is this clear? Do we have any problem? And if you will have any kind of problem, just write in comment section. Okay, we will reply you. Just don't worry about it. If you have any kind of problem, just write in the comment section. Okay, so is this clear? Am I understood? What is parallelogram law of vectors? See, these are the two main laws. First, a triangle. So if we take any two adjacent sides, in one order, the resultant vector will be the third side taken in the opposite order. And in parallelogram law of vectors, two adjacent sides taken, and see, these are in the same order. These are not in the same order. See, these more kind of a co-initial vectors. So and the diagonal, as having the common point between the two adjacent sides, the diagonal associated with it will, and the vector on it will be the resultant vector of these two vectors that we have taken. So R vector equals to A vector plus B vector. So the magnitude of R vector equals to root of A square plus B square plus 2AB cos theta. And theta being what? Theta being the angle between A and B. Is this clear? Am I understood? Okay. Is this clear? Am I understood? Do we have any problem? See, I know this is the very first lecture, so if you guys are having any kind of problem, like you want me to teach, you want to keep my pace a little slow, or you want to keep my pace little fast, or you are having any kind of personal problems, like personal problems related to study, that how to increase your study time or anything like that, you can just write comment, and I'll try to reply. It may be hard sometimes to reply on every other comment, but we'll assure that we will reply to the maximum comments that we can. Okay, so if you are having any problem, you can ask us. Okay, so I hope this is clear, the parallelogram law of vectors. And I really hope from you guys that you will be studying at home. Now this is the starting. Basically, you are not just preparing for 11th class right now, you are also preparing for class 12. So because very honestly, the preparation of class 12 begins from the very first day of class 11. So you are also preparing for class 12. Okay, so yeah, so that's it, guys. That's it for the today's lecture. So it is the first lecture, so we try to keep it short, and yeah, so I hope it went well, and you understood everything. So if you have any doubts, you can comment down, and you can also like the video. So yeah, that's it. Thank you so much for joining, and thank you.